Welcome. In part 2, we will learn about for and while loop and the break and continue statement, which are important statement if you want to exit or in case of break, or continue if you want to skip one of the loops. Okay, let's start. So a for loop, that's basically you keep iterating. You have an index, so here like you have an index variable, and then you keep iterating from like where this index start to this index end. With like you can use increment also, and then while for each iteration something will be executed. Okay, so let's just see an example. It's easier. So like for example, I want to loop for n is equal to 1 to 4, and then you similar to if statement, you need to end with the keyword end. So basically, I'm looping here for n equal to 1 to n equal to 4. Let me just display like what the simple thing we do. So basically, it's like the first iteration, n will be equal to 1, n will be equal to 2, n will be equal to 3, n will be equal to 4. And then you can just make anything, like you can say m is equal to n plus 2, for example. So if I loop through this, then like my first loop is n equal to 1. So here 1 plus 2, I got 3. My second iteration, n will be equal to 2. 2 plus 2, I got 4, and so on and so forth. Okay. You can also like loop with an increment. Let me show you an example. So I could say like 4. And that doesn't need to be n, that could be anything you want to use. Index is equal to like, so here try to loop from -8 to 12 with an increment of 4. So this is like -8 with an increment of 4 to 12, and then end. And then I could just display here my index, just simply display my index. Can you guess what will happen here? So my first iteration, that will be like -8. My second iteration, like my second loop, that would be -4. My third one, that would be 0, 4, 8 until like 12. So if I run this, then I got like -8, -4. So that's like I have like 1, 2, 3, 4, 5, 6, 7 loops here. And then again, like here, that could be, you can execute anything. You can say like x is equal to index time 2. And then like you take the absolute, for example. Okay. So if I run something like this, then I got like here my index, which in that case was like I'm starting with -8, so -8 times 2, that's 16, and then I take the absolute, that's like -16, then I take the absolute, then I get 16, so on and so forth. You can basically do like any, loops are especially useful, like because sometimes you want to index through an array. That's why like basically you do a loop. Let me show you an example like how you use a loop to index through an array. So I have an array here 10, like 30, 40, 50, 60. Okay. Then I want to loop from n 1 to 4, and then I want to index through a. Okay. So here a. So can you guess what will be the output of this code? So basically, for n equal to 1 means this, like I'm indexed to the first array of this one, n equal to 2, that would be like the second element, and third element, and fourth element. Let me run this and show you. Oops. Clear all output, something like this. So I have here, and I can say like, x, for example. So I have here like that's my a, then I'm saying like x is equal to a with like n, basically 1, a2, which would be this one, a3. I could make this also with an increment. So if I did something like this to a6, for example, then basically like my first iteration, that would be like n is equal to 1. So a1, that would be 10. My second iteration, that would be like I increment this by 4, so that would be n equal to 4. So a4, that would be like 40, something like this. Okay. If I, let's say, if I make this to, so that's like, that's how you can, that's basically like one useful thing for using a loop is basically you have like an array that you want to index to and using a loop. You could also have like a nested loop. So like a loop inside a loop. So for example, I'm telling you here, make an element of value, try nesting two loops. So I want to, for n is equal to 1 to n, which is like 4, and then for m is equal to n to m, which is 3, and then end, and then end. Okay, so now I have this, and then I'm telling you for this, try to find the row and index, like find the summation of like n plus m. That's what it's saying. So can you guess like what will happen here? So basically, what will happen here? We will like let me display this, like display n is equal to the number to string n plus m is equal to display number to string m plus n plus, oops, okay, let me start a new line, that's okay, n plus m is equal to, and then plus number to string, and then that would be x, for example. Okay, so can you guess what will happen here? So basically what will happen here, it will start by executing the outer loop starting by n1, and then for all, then it will execute all this inner loop. So basically it will go from, for n is equal to 1, it will execute m from all the m value, which is from 1 to m equal to 1 to m equal to 3. Okay, let me show you like how this will look like. Oops. Why is this displaying in a separate line? Let's put it over here on line. Okay, I don't want to display these x. Okay, yeah, that's okay. So here, let me clear all outputs. Come here. What am I doing here? What's happening here? Okay, here. So basically, that's exactly what happened. It for n is equal to 1, like start by executing this for n equal to 1, then it will loop for all the m. In m to loop for all the m, like m1, m2, m3. Okay, because m here like to m3, and then it will add them. So basically, 1 plus 1 that's equal to 2, 1 plus 2 that's equal to 3, and so on and so forth. And then it will move to the second loop, n is equal to 2, and then it will execute all m1, m2, m3. And then you can keep nesting, like you can do more, like you can say like for j is equal to 1 to 2, for example. And then like you end here, like remember you need to put the ends, and I could say like this plus j, nmj, and then I could, let's make it here, I could say like j is equal to n plus number to string j, okay, plus j, okay, something like this. So I can, if I run this, make space here, okay. So if I, So if I run this, basically it will start by like executing like the outer loop, which is like for all like n equal to 1, then like it will start by executing like the second outer loop, like m equal to 1, and then it will execute the most inner loop, like j equal to 1 and j equal to 2. Then it will move for n equal to 2. It will execute j equal 1 and j equal 2. Then it will move for m equals 3. So forth until it's done, then it will move for the second outer loop. Okay, so that's like how you can have like a nested loop. Okay, so here, this is like an exercise. So basically, you have like this equation, like c, which is a function of x and t. And all these are like just some constant. This is an error function, like this is how it looks like. You don't have to worry about it, like MATLAB can you just use error function and MATLAB will calculate this for you. And then it basically telling you plot x, all like the x value. So x, that could be like c, that could be like, for example, like a concentration inside a column. So you have a column that starts from x0 to L, that would be the length of the column. So here, like this, your x value, let me show you how your x value will look like, for example. So like your x, oh, that's 6, let's just make it 6. So you have a column which you discretize into 6 cell, like, so this is like, or 6 point, like your initial, like your inlet of the column, your exit of the column, and like some point inside the column. And then you want to see how this concentration progress with time. So basically that's x, how concentration move in the x and progress with time. So how can you do this? So basically you can just solve this as a loop for all the time t. So basically it tells you test this equation for t is equal to 1 to t is equal to 4. So for 4 time steps. So at each time step I want to see how the concentration progress inside my column. Okay, at each time step. So how can I do this? You just like use you loop for all time steps. So here we have the number of time steps are 4 because like we want, I'm telling you go from t1 to t4 like for each time step unit. So basically you say like 4t is equal to 1 to nt, and then you basically you write your equation. But before you start this, you need it's always a good idea to define like the output array before you start. So like the output array could be something like your concentration. That could be like, you could be nan, 0, whatever. And then what should this output array look like? It should have 4 rows, one for each time step. So that would be like nt. And it should have 6 columns, that would be for like your x, so that would be your nx. So it should look something like this. Let me, yeah, it doesn't matter, here I can do this. It should look something like this. So basically I have like a 4 by 6 array. So that first row here, that would be for all my x's at time 1. That would be for all my x's at time 2, at time 3, and time 4. Now I want to fill this. So with like time 1, time 2, time 3, and all my x's. So how can I do this? Then you just like loop through these rows one by one, and for each one I calculate my concentration. So here would be like c, and that would be like my t, which will like loop from t1 to 4. And then like all of it for all the x's, and that will be equal to c naught, that's already given here, plus cn, let me put a bracket, cn minus c naught divided by 2, so I can just multiply by this guy, error function, that's like how this error function in MATLAB is, x. So that would be like this array here, minus v time t. So v, it's just like a vector, like as a scalar, like v is equal to 1, and t, that would be like my first time, which would be 1 here. Okay, so I can do this. So this is like an error. This is like a 1D array, and these are just some like scalar value. And let me put like a bracket here, divided by 2. Let me put another bracket here, 2 times like square root of d time t. And d, like again, d like is a scalar here. So now I have something that looks like this, and then like let me do the plotting. So I plot, what am I plotting? I'm plotting my x and my c. So basically I will have like 4 plots for each x, like these x value I will have like c1, c at t1, t2, t3, and t4. Okay, and then like, let me just do like legend, for example. So that would be like t1, t2, like t3, and that would be like t4, and then like my x label, that would be like my x, the discretization of the column, and my y label, that would be like the concentration as a function of x and t. Okay, so if we let me run something like this. So here you see now I started, like I initialized this empty array of concentration, and then for t is equal to 1, like my first time step, I filled like this first like row here. For my second time step, I filled this one here. For my third time step, and like for my fourth time step, I like filled all of them. And then this is, you see how like your concentration is progressing with time. So you know, at like time 1 there was no concentration by the end of the column, like you have more of the concentration at the beginning here. At time 2, time 3, time 4, like at time 4 you start to see some of your concentration here, and so on. Okay, so that is something like this. Okay, you see this is kind of like not smooth. If you want to make this smooth, you can put like more nx here, like you put nx is equal to 60 or something. Okay, so if you put more x, then it's got like more smooth, like more discretization along the x direction. So here this is like more discretization along my column, so that become more smooth. Can you do this with vectorization? Yes, you can do this with vectorization. So let me show you like so see with a loop it is kind of something like this. Let me show you how to do this with the discretization. So with discretization, let me show you. So like my x is equal to line space, and then what should I put here? I should put here my so this from 0 to 5, I think. L is equal to 5, yes, from 0 to 5. And how many points do I need? Like nx. Okay, so now I have something that clear all output. So now I have something that looks like this. Well, I put here n is equal to 4. So I think I solved this for n is equal to 4. Let's just assume that this is equal to 4. Okay. Oh, okay. No, let's just keep it 5. Okay. And this like here that should be like 0 to L. Okay, to 5. Okay. And here let's just keep it like 0 to L, like to 5. And let me, I have like 6 points that are spaced like from 0 to 5, like for all my x's. Okay, so that's like 1 by 6 arrays, and my time is like, that would be, make here from 1 to nt, That's like, so you see, that is the thing, is that like this is a 1D like row vector, this is a 1D column vector, and I need to basically I need to repeat this one for all the t, because like x does not change for all the t, and then I need to repeat t for all the x, because t does not change for all the x. So how can I do this? So that I can just do this like element by element multiplication. So that is like, remember, like rep mat. So basically like you do rep mat, and like how do I want to repeat this? Like, so I have this guy, I want to repeat it like 4 times here. So basically that would be like nt, and like in the column direction I just want it to be 1 time. So let me show you this. So now I have all my x's from x equal to 0 to x equal to 5, and then repeat it for all that time, because for each time step I want to calculate like all like the concentration at all these x's. Okay, and then I do the same with time. So I have like rep mat, and then I repeat this one in the row direction just 1 time, and in the column direction I repeat it like nx time, like whatever number of x that I have here. So now, so basically for all my x's I will have like the same t, because at t1 I just want to calculate my concentration for all x's, at t2 and so on. So now I can just come here and do this without loop or anything. So I can just like, once I did this, I can just come here, that would be my c. Okay, so my c, that would be like all these things, x minus vt. So basically that would be like all this x array minus the t array here, then divided by t, like something like square root dt. Now here I must put this dot, because if I didn't put this dot, remember MATLAB treats this as a matrices, and this is as a matrices, so it will do matrix operation, but I just want to do this element by element. So I just like put like this dot here, I don't need this guy. Now when I plot also I need, like, remember now my x is something like this, but I don't want to, I just want it like 1x, so basically I can just select like x, I could just take the first row of x, okay? Because I will plot all my concentration, which will be like, so my concentration would be an array like 4 by 6, and I want to plot it for like just x, like any of these x, okay? So if I did this and I run it, then I got something that looks like this. So I just like, no loops, nothing. So it will be just calculate for T1, T2, T3, and T4. And then it will plot them. If I want to make this smoother, I could make this maybe 60 here. And then if I run this, then you see here I got like my T, my X, that would be 4 times 60, and then it's like repeated. My T, that would be 4 times 60, and that's like repeated, and then my concentration goes as a function of x and t, then I got like a T1, T2, T3, and T4. Concentration as a function of x and t. Okay, so that's something like this. Now this is like some extra exercise, like you can practice at home if you want to do more practice. Here is this extra problem. Okay. Now here, this is the while loop. So while loop is slightly different than for loop. Like for loop, you keep executing like from 1 to end, like from not 1 to end, like from your start point to your end point. So the loop will end once you reach the end of your index, or like the end of your variable here. Okay. While loop, it will, like, you have an expression here, you will just keep looping as long as this expression is true. So if that expression remained true, you could just loop for infinity, basically. But once this expression is no longer true, then the loop will exit. Let me show you an example. Like, so here I have like n is equal to minus 2. Execute this loop as long as n is less than or equal to 5. So basically, that's how to do this. While, you write like while n less than or equal to 5, then you will do the loop and execute whatever you want to execute here. So maybe we can execute here like n is equal to n plus 2. Okay, that's how you can, that's the only way you can exit this loop. Otherwise it will be an infinite loop. Like you just keep incrementing n until it reaches the value of 5. So if you can you guess what will be the output of this loop? So basically it will start looping. In the first iteration, n, which is minus 2, will be plus 2, so you'll get 0. In the second iteration, you will get 2. In the third iteration, you'll get 4. In the fourth iteration, you will get 6. And then in the fifth iteration, what will happen? Nothing. It will exit, because now 6 is, n is now less than or equal 5? No. And now 6 is not less than or equal 5. 6 is larger than 5, so it will exit. So here if I run this just as I expected, like so in my first iteration, like n goes here so that I get n equal to 0. In my second iteration, now n is like 0 plus 2, I got 2. Now in the third iteration, n is now new value of n is like 2 plus 2, I got 4. In the fourth iteration, 4 plus 2, I got 6. In the fifth iteration, 6. Is it less than or equal 5? No. No. Then I exit the loop. So here, I mean, this is just like an exercise. Generate a random number between like 0 and 1. This will be your target. So here, that would be my target. Like that could be any random number generating. Keep guessing until the guess is close to the target by less than or equal 0.05. So here, I will like, that's my target, like you can just put any number or generate it like randomly. That's the number you're trying to guess, and then you try to keep guessing until like your error here, like which is the difference between your guess and target, is less than or equal 0.05. Okay, so while, let's say like error, like while like as long as the error is like larger than or equal 0.05. So as long as this error is like larger than this, something keeps looping, because I want my error to be less than this. So as long as it's larger than, just keep looping, keep guessing. Okay, then n. Then I can say here, like, so I can make like my guess again, like you guess is up here like a random number, another random number. So like, okay, and then like my error will be the guess minus the target. And you might want to put like absolute value, because like to avoid like getting like negative numbers. So you just put like an absolute value. So if you run this, and here maybe you can display the number, the target, and the guess, and the number of trial, how many times. So like if we run this, oops, let me you can clear, or maybe let's not, okay, let's just display the guess. Okay, so here let's start here. So like I started, like my target is that's like the number was randomly generated here. Okay, and then I start by like any error here. Now like my guess, my first guess was 0.14. That's like very far away from this. My second guess was this, very far away from this. My third guess was this, and so that is like the difference between like this guy and this guy is less than 0.005. Then your guess is this, and the target is this, the number of trial is 7. Like if I want to make this number much smaller, like I want like my guess to be much more accurate, then of course this number, like this loop will keep going for longer, because that's more difficult. Like you see here, keeps going for longer and longer and longer and longer, and then like your guess is this, the target is this, and the number of trial is okay. So here like the number of trial, if I how could I count the number of trial? Basically you could put like a counter, so like you could put like a counter is equal to 0. Okay, so I put like, and then I see like counter is equal to counter plus 1. So now I'm counting like how many loops are counter. Okay. Oh, we can. So basically, yes, a counter will keep incrementing. So here, that's like my target, and now I find like your guess is this, and the target is this. The number of trial is like 29. Okay, so that is something like this one. Here, this is some extra exercise if you want to do more practice. And now we have like two more things, like very useful, which is like the break and continue. Both are useful for controlling the flow of loop and skipping over or terminating loop iteration based on like a certain condition. The break statement is used to exit a loop prematurely when a certain condition is met. So basically, for example, I'm giving you here an example, like I tell you, loop array V, so you have an array V, and break if Vn, like any of element is less than 0. Like when you encounter a negative element, just breaks through this loop, don't continue with the loop, and then display Vn. So basically that's my V. So now like the length of the V, like how many elements, like the length is like the number of elements in the largest dimensions, so that would be like 6 here, for example, like, and then I loop from 1 to 6, and then if Vn is less than 0, then break, like exit this loop, and then I display my Vn. So if I run this, guess what will happen? It will display 1, it will display 2, it will display 3, and that's it, because it will come here is Vn, like element number 4, which would be like this one, is less than 0. Yes, it is less than 0, then it will break, and it will not gonna display like -4, 5, and 6. Okay, so here, okay, let me put like a section break and run clear all output. So if I run this, here all output, and put like a section break. Where? Section break, okay, here. So basically that will be like, if I, let me disable, like if I don't have like this break condition, then the loop will just continue all the way to the end. So it basically display like 1, 2, 3, -4, 5. But since I have this break condition, and this break condition could be anything. It could be like break if Vn is like larger than 5, for example. So like if I put like this condition, it will basically keep going. It will display until 5, but at 6 it will not display 6. Why? Because Vn, like when n is equal to 6, that's like, so here that will just display until 5, something like this. Okay. The continue statement is used to skip the current iteration of a loop when a certain condition is met, and continue with the next iteration of the loop. So basically here I'm like, I want to only display like, let's say it's a positive number. I don't want to display like any negative number. So basically I just put like, so I'm looping here from 1 to n, which is the length of this guy, and like if any of these elements, like, so I'm indexing through v with this n, So if any of these elements is less than 0, continue. Then continue means what? It means that do not, like, whatever is commands you have here, do not execute them, just increment the loop, move to the next iteration. So that's what continue means. Continue means that this is not going to happen. So can you guess what would be the output of this? So basically the output of this, it will like index through, like, let's put here like 10, 20, minus 30, 40, 50, 60. So basically what will do, it will index through this V. So like it will like be like, it will check, like V1 will be displayed, V2 will be displayed, V3 that will be skipped because it will come here, V3 less than 0, yes. Continue means that it will go, it will not like display like this guy, but it will go to the next one, and so on. So basically here that will only display the positive number. So if I did this 10, 20, 40, and 60. Okay, so these are very useful like statement if to control like your loop, if you want to exit the loop or if you just want to skip one of the iteration of the loop. Okay, that's all for this loop lesson, and see you in the next lesson. In the next lesson we will be doing practice, basically like we will practicing using loop and vectorization. So I will show you some problems. We will first like solve them with loops or like vectorization, and then with loop, and we will see which one is easier. And so it will be like more of an exercise and practice. Okay, so see you.